So linear functions, this is going to be a very quick recap because this is something you've been doing for a number of years. If there's anything you don't know, then please come and ask or go back and do some revision. But here goes. Straight lines. So they generally have the form, or we write them, as y equals mx plus b. And the reason we do this is because that's the gradient intercept form. So if you've got it written in the form y equals something x plus something else, the m is the gradient and the b is the intercept, and you can read them straight off the equation. The other form that we use is the general form, and that's where we have ax plus by plus c. A is a positive integer, b is an integer, so no fractions or decimals for either of those. And we do that because then we can use the a and the b and the c in things like some of the formulas that we're given to work out gradients, intercepts, find the equations of lines and things like that. So you've got the two forms. You have to be able to graph from either. You have to be able to manipulate either. So looking at this first one, we're asked to graph y equals 3x plus 5. So the easiest way to graph these lines is to work out the x and y intercept. Because it's a straight line, you only need 2 points. So to work out the x-intercept, we're going to substitute in y is equal to 0. So you get 0 is equal to 3x plus 5. So what that means is that negative 5 is equal to 3x, or x is equal to negative 5 over 3. And then to work out the other intercept, you're going to substitute in x is equal to 0. So your y-intercept is y equals 5. So our x-intercept is minus 5/3. So it's minus 1 2/3. So we're going to put that there. Our y-intercept is 5. 1, 2, 3, 4, 5. And then you draw your line. And that's how you graph the straight line. So because it was y equals 3x plus 5, you should have been able to read off the fact that the y-intercept is going to be 5 anyway, because that's that number being added on. Your gradient is 3, so what that means is every time the line goes across 1, it goes up 3 squares. So the other thing you can do using y equals 3x plus 5 is work out your y-intercept and then say, well, I know that every time I go across 1, it's risen 3 spots. And you can find a couple of points that way. A couple of exceptions to this rule though. The method can be used to graph any straight line that's in either of those forms, but things change in this case. These are two special kind of lines. So the graph of x equals 5. So think about it, x is equal to 5, so it has to cross through x is equal to 5, and x is always going to equal 5. So when you graph that, it's going through x is equal to 5. So that's what the graph of x equals 5 looks like. And if it was x equals 3, then it would cross at 3. If it was x equals negative 2, then it would cross at negative 2, etc., etc. Whenever you get an equation x equals a constant, you get a vertical line. So what about y equals 2? Well, if x gives vertical, y has to give horizontal, doesn't it? It crosses through at y is equal to 2. And y is always equal to 2. It doesn't go up and down. There is no gradient change here. It's 0. So the vertical line, x equals 5, well, this is not a function. Every value of x does not have one and only one value of y here. So this is not a function, but y equals 2 is a function. So sometimes thinking about these things, you need to give it a bit more thought. You can't just jump straight to an answer. Anyway, that's what you need to do exercise 5.4. Good luck, and I'll see you in class.